Hello everyone, I am Anjan and welcome to the third video tutorial of the Verilog course series. In this video, you will be getting to know how the half subtractor works and how to design a Verilog code for half subtractor using behavioral modeling style. For a better understanding, I split the video into three parts, that is pre-coding part, coding part and the post-coding part. Now we will be seeing the pre-coding part. In the pre-coding part, you will be getting to know how the circuit diagram works with half subtractor and the nature of the truth table. Now, what is a half subtractor? Half subtractor is a circuit which is capable of taking two 1-bit binary numbers as input and getting output as difference and borrow for these two 1-bit binary numbers. Now, coming to the truth table, you will be observing a nature of the truth table that you will be having three cases, that is difference and borrow as 0, 0 as the first case, where you will be seeing two outputs for the two same outputs 0, 0. This is case 1, and case 2 as 1, 1, and case 3 as 1, 0. I will be using these three cases in my Verilog code designing, and I will be using these three cases by else if statements. Now let's move to the coding part. In the coding part, you will be observing that I declared half sub as the module name and I taken x and y as the inputs in place of a and b, and diff and borrow as the same in case of these outputs. I declared reg as I declared diff and borrow as in the reg form because they stores the output value in them. So I declared it as reg form. And coming to the sensitivity list, I declared in the x and y variables in the sensitivity list, because if one or both the variables of x and y changes, the output will affects. Now in the if statements, if and else if statements, I used these two conditions which repeats only once, that is 0, 0, that is 1, 1 and 1, 0. 0, 1 and 1, 0. And the other case, that is else, we will be getting output as 0, 0. Here it is 0, 0. That is the case for 0, 0 and 1, 1. Here it is. If x equal to 0 and y equal to 1, if both are true, this implies these two ampersands implies if both are true, this condition will execution. Else, if these two conditions are true, then this will operates. Else this will operate. Now we shall move to the post coding part. I just copy paste the whole thing here in the software, ViewAuto software. I already simulated it for you, but I didn't give any values to it. Now I will be giving to the values. In the truth table order, I will be giving the values. First is x equal to 0 and y equal to 0. I will be getting the output that 0, 0. Yes, I got the same one. Now x equal to 0 and y equal to 1. I will be getting the output as, let me see, as 1, 1. Yeah, I got it, 1, 1. Now I will be giving 1, 0. I got 1 comma 0, right? And now I will be giving 1 comma 1, so that I will get 0 comma 0. Here I got it. Now I will show all the signals from the initial to the beginning using zoom fit. Here you can see all the given inputs and what the outputs we got generated. Now coming to the schematic, you will be seeing the different schematic compared to the which you saw in the pre-coding part. That is, you will be seeing only the XOR gate and the AND gate and a NOT gate, but here you will be seeing 5 cells, that is n 2:1 mux, 2 AND gates, 2 equators. But the functionality of these two circuits, that is in the pre-coding circuit and this circuit, are the same. Why this different circuit came is because we are using the behavioral modeling. Though if you want to get the same circuit which you saw in the pre-coding, you should be doing the data flow modeling or the gate flow modeling. Just pause the video and try for a while. If you got it, it's good. Otherwise, I will be showing the code for gate flow modeling. Here is the half subtractor gate flow modeling. Here I declared XOR gate, NOT gate and AND gate, which are getting the outputs D, Y and borrow. No need to worry, I will be pasting this whole code in the description box. If you like the video, do like, share and subscribe to the Start Scratch. Keep learning.